So we need to state non-permissible values before we add these out. So we're going to look at the denominator for non-permissible values. So the denominator is where we find those. We do not worry about the numerator for non-permissible values because it's only about dividing by 0. So x is not equal to +2, -4 from those factors. Once we do that, we need to add these together, so we need a common denominator. To find a common denominator, we look at the factors. That whole bracket x minus 2 is a factor, and the whole brackets of x plus 4 is a factor. Now, when we find a common denominator, we just look each fraction looks at each other and asks what factor is missing in the denominator. So the right-hand fraction is missing an x minus 2 factor. So we need to get an x minus 2 down there. But if we're going to put one in the denominator, we need to balance the fraction to put x minus 2 on top as well. So same thing for the left fraction. It's missing an x plus 4. So we need an x plus 4 on top and bottom. And now we have a common denominator. We can then expand out the numerator and add them together. So I'm going to expand out the numerator, 2x plus 8 plus, I'm just going to put this in brackets to group this together. We're going to expand those binomials. So x squared minus 3 minus 2 is minus 5x. Negative times negative is positive. That's going to give us plus 6. So then the denominator is going to be our x plus 4, x minus 2. Combine the numerator, we end up with x squared minus 3x plus 14. And that's all over our denominator of x plus 4, x minus 2. We could check to see if the numerator is factorable to see if there's any common factors, but there's no two numbers that multiply to 14 and add to -3. So that's our final answer. For number 6, we want to solve this system of equations. So we have it both y equals, so we could do elimination by subtraction or by substitution. In this case here, we're going to use just this y equation is going to equal, so 2x minus 1 is going to equal the other y equation here, negative 2x squared plus 3x. So we essentially replace the y with the other expression. So once we've done that, we now have an equation to solve for with one variable. It's a quadratic, so I'm going to move everything. Actually, I'm going to move everything to the left-hand side here because I don't like that negative x squared. So I'm going to get positive 2x squared plus, oops, that's not going to be plus, that's going to be, so I'm going to subtract 3 from both sides, 3x. So I get negative x minus 1 equals 0. I can try factoring this. So if I sketch my little grid here, 2x squared, negative 1. So two numbers that multiply to negative 2 and add to negative 1 are going to be positive 1x and negative 2x. So I get 2x, looks like plus 1, x minus 1. So there's my factored form. And solving for x, I could have just put it into quadratic formula as well. But it was easily factorable, so I'm going to go ahead and factor that, and I get my solutions. Now, since this is a system of equations, it's not good enough to just get the x. I also need a y to go with that x. Okay, so when x is negative 1/2, the y that goes with it, I need to plug it back into the original one of the equations. Now the red equation is much easier to plug into. So I'm going to get negative 1/2 times 2 is negative 1, minus 1 is negative 2. So there's one set of solutions here. My other set of solutions is when x is equal to 1, plugging that in, I'm going to end up with y equals 1, and that represents my other solution here. Okay, so we can check this solution on a graphing tool. Now, I don't have a graphing tool with me, but we can graph this fairly easily. We have the parabola. It's got a 0 at 0, and if I factor that out, we're going to end up with negative 2, so x minus 3, 2/3. So x is going to be about 2/3, so somewhere around there. So it's going to be 3/2. Okay, so it's going to be, we're going to end up with 3/2, positive 3/2 as the other solution. And we're going to end up with a parabola that's upside down. So it's going to look kind of like this through there. 2x minus 1 is going to be, actually, I want to trim this a little bit. This is a funny shape here. Okay, and then the 2x minus 1 is going to be a steep parabola, or steep linear equation that's going to go through at x equals 1, maybe somewhere. X equals 1 is somewhere up there. Okay, so we're going to have our two solutions here, negative 1/2 and negative 2, and at 1 and positive 1. Okay, so I probably should have drawn this a little bit more accurately, but the general solution is going to look like that when we graph this on our graphing tool.